One of the design principles widely followed in software engineering for application extensibility is to separate the application into two layers, an abstract layer and a concrete layer. This gives you the freedom to change the implementation layer while keeping the abstract layer the same and keeping the external users of the application unimpacted. This lesson covers how this principle is applied in DAML applications using DAML interfaces. The DAML interface is an abstract type that has three key components. First is the view record of type viewType. All interfaces have a special method called view, which returns a value of the type declared by viewType, which is a record. When a template implements an interface, it provides values for the fields in this view record, which can then be used by the methods and choices. The second component is the method signatures. These methods need to be implemented by the template that implements this interface. The third component is the choices that the template will get when implementing this interface. The choices are fully coded in the interface body, but they use the methods that are yet to be implemented by the template. There are three key tasks for a template to implement an interface. First, create an instance of the interface. Second, provide data for its view record. Third, implement its methods. Let us look at a scenario to understand how this works. Let us say that a bank creates 5 transfer proposals to transfer $1 each of cash to Alice. It also creates 5 transfer proposals to transfer $1 each of bonds to Bob. Both Alice and Bob accept these proposals. Then, Alice wants to swap one of her $1 cash with Bob's $1 bond. So, she creates an asset swap proposal for Bob, which Bob accepts. Let us see how we will design this using DAML code. One way is to have a cash template, a bond template, and transfer proposals for each of them, so that you can use the propose accept pattern. For a party to swap cash with bond, it will need a cash to bond swap proposal because the data types of what is offered is different from what is requested. So far, so good. But the problem in this design is that if the business wants to swap another type of instrument, such as a token, you need more swap proposals. Since swap functionality is used by a front-end application, it must also be changed. Also, as indicated by the direction of arrows, these swap proposals depend on the underlying cash and bond templates, which in turn have their own dependencies. So the front-end application is impacted by changes in any of these dependencies. This design approach makes your application brittle and difficult to extend. DAML interfaces address this problem. You can create an interface layer that has 4 components needed for the asset swap scenario. The first component is an interface called iAsset that will be implemented by instruments such as cash and bond. This interface has vAsset as its view type. Recall that this view type is a record that contains data about the asset. The vAsset record has issuer, owner, observers, quantity, and a set type. The value in the asset type field will differentiate cash from bond. There are 4 method signatures: set owner, set obs, set quantity, and transfer to. The interface provides only the signature. The templates must implement these methods. Finally, there are 3 choices: set observers, propose transfer, and transfer. Since each asset type requires its own transfer proposal, you need another interface shown here called iTransferProposal. Note that it has its own record vTransferProposal for view type and asset of type iAsset in its field. It has one choice named AcceptTransfer, which returns a contract ID of type iAsset. Also note that there is no direct reference to any of the specific asset types, such as cash or bond. Now, your interface layer design is ready. Here is the implementation layer in the Assets module. The cash and bond templates implement the iAsset interface. For that, they will create an instance of the interface and implement the 4 methods: set owner, set obs, set quantity, and transfer to. Similarly, the bond transfer proposal and cash transfer proposals implement the I-transfer proposal interface. Once you have these two layers set up, you can create the swap functionality by using the I-asset interface from the interface layer. This way, it will not get impacted by any changes in the implementation layer. It also allows adding new types of assets, making swap functionality extensible. Now, let us look at the code. First, the Interfaces module is in a package named Extensible Swap. The V-asset data record is defined here with issuer, owner, OBS, quantity, and asset type. This is then used as view type in the I-asset interface. There are 4 method signatures: set owner, set OBS, set quantity, and transfer to. The 3 choices are set observers, propose transfer, and transfer. This interface is implemented by the cache template. The template has its own fields: issuer, owner, OBS, and quantity. In the where block, it creates an instance of the interface in the line interface instance I-asset for cache where. Within this where block, 2 things are implemented. First, it allocates V-asset values to the view with asset type as cache. Then, it implements the 4 functions from the interface. Note the use of the toInterface function here. The toInterface function converts a template value into an interface value. In this code, the function this will give the value of cache type, but the function signature should evaluate to I-asset type. So toInterface will convert cache to its interface I-asset type. There are several other functions in the DAML library, such as from interface, toInterface contract ID, and from interface contract ID, that you will find useful when working with DAML interfaces. Also note that these methods are pure code. They do not have a ledger interaction. This is important because it allows them to be later combined in the choices, if required, without adding extraneous intermediate ledger events. Similarly, the bond template implements the I-asset template. In this example, we have only asset type assigned to the text value bond, and the transfer to function using bond transfer proposal. In a real-world application, the differences between cache and bond asset types will be much more complex. Finally, there is I-transfer proposal that has the view type V-transfer proposal and one choice named accept transfer. Notice that there are no methods in it, which may happen in some interfaces. The 2 templates implementing this interface are cache transfer proposal and bond transfer proposal. Now, you have the interface and the implementation layer ready to build the swap functionality. In this swap module, there is an asset swap proposal template. It takes requester and receiver as 2 parties, offer spec and requested spec as 2 tuples, and contract ID of the I-asset offered for swap. In the settle choice, you exercise the transfer choice on both of them, one by one. This completes the swap. As you may already know, a swap in a real-world scenario will have many more checks and balances before the transfer happens, but this should give you a basic idea of how interfaces work. The key idea is that the swap functionality did not have to know which types of assets are being swapped as long as they have implemented the I-asset interface. Finally, let us look at the script to play out the scenario. First, set up the ledger starting state by creating some parties, using the initParties script, which creates 3 parties: pbank, palice, and pbob. This script returns the test scripts to be used in setting up initial assets. Init_assets creates the payload for cache and bond. Then, pbank creates 5 cache transfer proposals for Alice and 5 bond transfer proposals for Bob. Finally, Alice and Bob accept the proposals, which creates assets for them. If you run this script, the ledger will look like this. Alice has 5 cache assets, and Bob has 5 bond assets. Now, let us test the swap template. Run the init_asset script to get assets ready. Then, Alice gets 1 cache asset ready to swap. On that asset, She exercises the set observer's choice to make Bob an observer. Note the use of the toInterface contract ID function to convert the cache CID to its interface iAsset CID. Then, prepare the offer spec and requested spec for cache and bond, respectively. Then, Alice creates a swap proposal, making herself as requester, and Bob as receiver, as well as giving the offer and requested specs. Then, Bob queries the bonds to find one bond that matches the requested spec. Finally, Bob settles the choice. When you run this script, here is what the ledger will look like. You can see that Alice now has a bond and Bob now has a cache asset. Let us now summarize. DAML interfaces have a view type record, method signatures, and choices. The choices are fully implemented, but the methods are not. DAML templates can implement these interfaces by creating an interface instance, filling data in the view type record, and implementing the methods. DAML interfaces help you build extensible DAML applications. For that, you create an interface layer that contains all the interfaces. This layer forms the API that the front-end application can use. The second layer will have the interface implementations. Separating the two layers gives you the flexibility to add new features and helps make your upgrades easier as your DAML application evolves.